Okay, guys, so here is another example of what you can expect to see on your SLO post-test. There is going to be a question that has a graph similar to this. This is a graph showing us the temperature ranges at which certain organisms prefer to live in the ocean. And this graph specifically already sets it up for you to give you the answer to the question, which the question would be something like, at which temperature range would you see the most competition? Well, it's probably going to be right between those dotted lines, right? It's going to be probably right about here, about 18 degrees Celsius to about 42 degrees Celsius, in between that range, because that's where we have the most organisms kind of line up, right? So you're going to see a question like this. And this pretty much shows me that the Antarctic ice fish is not going to compete because he prefers a much lower temperature, which makes sense because of his name. Also, thermophilic bacteria, thermo meaning heat and philic meaning loving, they love heat, they prefer warmer temperature. So these guys probably aren't going to compete for things with the other ones, but everybody lining up right about here would be in competition for resources. All right, so just make sure that you really pay close attention to those graphs when you're taking the SLO post test. All right, let's move on to our next concept, which is going to be everybody's favorite, sexy Isaac Newton, Sir Isaac Newton, excuse me. Should remember that from class. Like I said, you guys did really good on this in class. You did really good on it. We did a Google form a couple weeks back. I think it was like the second week of distance learning. You guys did pretty good on that, especially when it came to second law. So let's go through it really, really fast. First law of motion, an object at rest or in motion stays that way until changed by an unbalanced force. Keyword, unbalanced force, right? Remember we did this in class where we flicked the index card and the penny fell down. Well, the penny fell down because the unbalanced force that made it fall down was, you remember, gravity, right? Gravity is what makes it fall down. On the other hand, over here in this example, our poor little test tube guy, on his skateboard, the skateboard stops moving because the unbalanced force of this rock stops it. But unfortunately, Mr. Test Tube, nothing stopped him. There was no unbalanced force to stop him, so he kept going. He stayed in motion. This is the reason why we wear seatbelts, or we should be. All right, let's go over second law of motion. Second law of motion states the more force applied to a mass is going to result in more acceleration. So we have this example right here. This guy pushing with a little bit of force, right? And he's accelerating quite a bit. If we apply more force, obviously he's going to move faster, right? We could reverse that with saying, if I apply force to a mass, it's going to accelerate. But if I add more mass, I got to push harder, right? Or else if I push with the same amount of force, then I'm going to have less acceleration. People that understand this the best are usually my athletes, especially my football players who know what it's like to push a mass, whether it's a small mass or a large mass. All right, last law of motion, my favorite law of motion. Oh, before I jump, I'm sorry. Don't forget that the second law of motion also includes the formula chart. So do remember that force equals mass times acceleration. I believe you have one question on the SLO that involves the formula, so make sure you pay close attention. I gave you some hints there, so just make sure you read very closely. All right, now the third law of motion, my favorite law of motion. For every action, there is an equal and opposite reaction. Keywords, equal and opposite, right? So if I step off of this boat, I'm going to move, my action is I'm going to move to the left, but the boat is going to move in reaction to the right with an equal amount of force, right? So opposite directions. The same thing applies when I let air go out of a balloon. Air is going to go down, the balloon's going to go up, right? Equal and opposite. All right, that should be it for Newton's laws. Let's move on to the one you guys did really well on in class, components of the universe. If you recall, Uncle Gary needs some pretty mamacitas. I think we also had, I don't remember it now. My first period had a different saying. Maybe one of you guys will remember it, but we used Uncle Gary needs some pretty mamacitas to remember that we go from bigger to smaller, starting with the universe, galaxy, nebula, star, planet, and moon. All right, so let's go over each one. Universe, all of space and time, everything. You are part of the universe, right? Within the universe, we have galaxies. Now, there were three types of galaxies, I think spiral, elliptical, and irregular, right? But we're only going to kind of focus on spiral galaxy. It's not too important for you to remember all three of them for the SLO test. Just remember that we live in a spiral galaxy. It's called the Milky Way galaxy, right? And a galaxy is billions of stars held together by the big G, gravity, right?